In the murky depths of a singular lake, a nearly imperceptible arrival occurred. Creatures no larger than a human fingernail, delicate enough to be crushed effortlessly, began an almost silent invasion. Yet, within a mere handful of years, their presence had become continental, choking vital pipelines, submerging critical navigational markers, and siphoning billions of dollars from concerted efforts to halt their advance. Human ingenuity responded with an arsenal of chemicals, powerful scrapers, and resilient steel. But the most formidable countermeasure to this relentless biological onslaught would not emerge from human design. It was already resident in the very waters they conquered, patiently awaiting its opportune moment. The narrative unfolds in the year 1988, within the shallow expanse of Lake St. Clair, nestled between Lake Huron and Lake Erie, on the boundary separating Michigan and Ontario. There, a field researcher, collecting a sample of mud and shells from the lakebed, discovered an anomaly. It was a diminutive, striped shellfish, no longer than a thumbnail, adorned with the distinctive dark zigzag bands that would ultimately bestow its name. The zebra mussel had made its entry into North America, and the continent's serene lakes would never again retain their original character. It neither swam across vast oceans, nor trekked over land. Its journey, like that of countless other invasive species, unfolded covertly within the ballasted tanks of enormous ocean freighters. Vessels traversing from the distant shores of Europe and Western Asia absorb immense volumes of water in far-flung ports to maintain stability and balance during their voyages across the sea. Within this taken-on water floated the microscopic larvae of a mussel indigenous to the river systems and inland seas of the Caspian and Black Sea regions. Upon reaching the Great Lakes, these ships would discharge their tanks to accommodate new cargo, inadvertently unleashing a living entity into an environment utterly unacquainted with its presence. It was a world wholly unprepared, possessing no defenses and no concept of how to mount a resistance. This, then, is the insidious peril inherent in global shipping. For over 100 years, ships have silently transported minute passengers from one ocean to another. Larvae, eggs, and spores, concealed within the dark confines of ballast tanks. While most of these inadvertent voyagers perish, occasionally one discovers a pristine new habitat perfectly suited to its needs, a place offering the ideal temperature, abundant nourishment, and a complete absence of natural adversaries. For the zebra mussel, the Great Lakes represented precisely that flawless sanctuary. The waters were cool and exceptionally rich. The lake bottom offered an abundance of hard surfaces upon which to securely attach. Crucially, no native species within this ecosystem had co-evolved alongside this organism, meaning nothing possessed an innate mechanism to keep its proliferation in check. The true peril of the zebra mussel lies not in its size, but in its extraordinary reproductive capacity. A single female can unleash up to 1 million eggs within a single year. These larvae, known as veligers, are so minuscule they are almost imperceptible, drifting on the lake currents for weeks before finally settling. When they do, they cling with tenacity. Each mussel develops a cluster of robust fibers, termed byssal threads, anchoring itself to virtually any hard substrate it encounters. Rocks, docks, boat hulls, the shells of indigenous mussels, or the smooth interior of a pipe. Once one generation firmly establishes itself, subsequent generations settle directly atop it, forming layer upon layer, until a single square meter of lake bottom can support tens of thousands of individuals, stacked together in a living, calcified crust. From that solitary shallow lake, the ensuing proliferation was nothing short of astonishing. Within a mere decade, zebra mussels had colonized all 5 Great Lakes and began their relentless push down into the vast Mississippi River system. Catching rides on barges and clinging to the hulls and trailers of recreational boats, they leapfrogged from one lake to the next. They reached the Hudson River in the east, and later appeared in the Tennessee and Ohio river systems. They emerged in reservoirs scattered across the American heartland, hundreds of miles from any established shipping lane. A creature that had traversed an entire ocean by accident was now methodically conquering a continent under its own power, inadvertently carried by the very populace who desperately sought to contain it. For a period, the most apparent transformation was strikingly beautiful. Zebra mussels are highly efficient filter feeders. Each individual draws lake water through one siphon and expels it through another, meticulously straining out the minuscule floating plants and particles suspended in the current. A single mussel possesses the capacity to filter approximately 1 liter of water daily, and a dense colony can process an astonishing volume. In certain lakes, the water visibly transformed before observers' very eyes, shifting from an opaque, green broth into something remarkably clear. Swimmers and boaters could suddenly discern objects 10, 15, even 20 feet down, to a lakebed that had been obscured for as long as anyone could recall. To many, it appeared as though the lakes were becoming pristine. However, that newfound clarity was a stark warning, not an ecological boon. The microscopic plankton these mussels were systematically stripping from the water was not pollution. It was the fundamental cornerstone of the entire aquatic food web. These tiny floating plants nourished an array of tiny floating animals, which in turn sustained small fish, which then fed larger fish, which ultimately supported birds and human communities. By filtering the water until it ran transparent, the mussels were surreptitiously extracting the foundational support from a venerable and intricate ecological edifice. Everything resting above it began to destabilize. Native fish species that relied on open water plankton populations began to experience a precipitous decline. Indigenous mussels, suffocated beneath dense blankets of zebra mussels growing directly upon their shells, slowly began to perish. The lakes were not improving in health. They were being systematically hollowed out from their very base. Then came the widespread damage that proved impossible to disregard. Zebra mussels exhibit a distinct attraction to flowing water, the steady, reliable currents that course through pipes. This is precisely the type of water upon which power plants, manufacturing facilities, and municipal water systems critically depend. The mussels rapidly colonized intake structures, packing themselves into the openings with such density that the once vigorous flow dwindled from a forceful rush to a mere trickle. In Monroe, Michigan, a substantial power plant drawing water from Lake Erie discovered one of its intake tunnels so thoroughly obstructed with mussels that the facility was forced into an emergency shutdown. Crews were then tasked with the arduous, hand-laborious process of clearing the blockages. Throughout the region, drinking water treatment facilities and electric utility providers confronted the same relentless adversary and the same astronomical cleaning expenses, season after season, with no discernible end in sight. The financial figures escalated swiftly and reached alarming heights. Initial projections warned that zebra mussels could impose a cost of as much as $5 billion on the American economy over a single decade. This staggering sum was repeatedly cited in newspapers and official government reports until it became firmly ingrained in the public consciousness regarding the invasion. Later, more rigorous and conservative investigations specifically focused on particular industries, endeavoring to precisely quantify actual expenditures. These studies revealed that drinking water and electric power facilities alone had dispersed more than $267 million, grappling with the mussels over an approximate period of 15 years. Irrespective of which figure one chooses to acknowledge, the underlying message was undeniable. This diminutive, soft-bodied organism had emerged as one of the most financially ruinous invasive species in the history of the United States. Consequently, America mobilized its defenses, fighting back with immense resolve and employing every resource at its disposal. Operators introduced chlorine and an array of other chemicals into intake pipes, aiming to eliminate drifting larvae before they could anchor and proliferate. Expert divers descended into the frigid, dark waters to manually dislodge thick colonies from submerged infrastructure. Specialized fine screens and filters were installed, while metal surfaces were coated with toxic paints specifically engineered to repel any creature attempting to attach itself. Clogged pipes were subjected to powerful jets of high-pressure water, and in some instances, scalding hot water was circulated through entire systems until the mussels within could no longer withstand the extreme temperatures. Whole new engineering disciplines emerged, dedicated to the singular objective of preventing one small creature from gaining a foothold. Some of these interventions yielded temporary success, at least in localized areas, and for a limited period. A treated pipe could be maintained clear. A single intake structure might be safeguarded throughout an entire summer. Yet the vast lake on the opposite side of the barrier never ceased its relentless production of mussels. For every colony laboriously scraped away by a diver, 1 million more larvae were already adrift in the currents, poised to settle the very instant the chemicals dissipated and surfaces became quiescent. The battle proved interminable, extraordinarily expensive, and never once culminated in a definitive victory. It merely purchased precious time, one cleaning, one chemical treatment, one diver's shift at a time. And here lies the chapter of this story that largely escaped public attention. While engineers were prosecuting their war at the intake pipes, something entirely different was gradually unfolding in the expansive open waters. The indigenous inhabitants of these lakes, the diverse fish populations, the myriad birds, and the specialized diving ducks that had thrived in this environment for thousands of years, were also beginning to register the presence of the newcomer. And remarkably, some of them were starting to discover that this peculiar little invader, this costly and infuriating nuisance, posed no threat to them whatsoever. Instead, it represented a bountiful source of sustenance. The ecological response that human beings could never procure with $5 billion, nature was poised to deliver without cost. The first to respond were the avian inhabitants. Every autumn, the skies above the Great Lakes become alive with the urgent rush of migrating waterfowl journeying south ahead of the impending cold. Among these are the diving ducks, a remarkable group of birds anatomically engineered for a life beneath the surface. While their more familiar dabbling counterparts merely tip forward to feed near the water's surface, diving ducks vanish completely, propelling themselves downward with powerful legs positioned far back on their bodies, driving through the frigid depths toward the lake floor. They are, in essence, feathered submarines. For these birds, the sudden, explosive proliferation of zebra mussels across the shallow reefs and bays was not a catastrophe in any sense. It was the single largest feast they had ever encountered. When scientists meticulously analyzed the actual dietary intake of these ducks subsequent to the invasion, the findings were truly astonishing. For the lesser scaup, a small, agile diving duck characterized by a steel blue bill and golden eyes, zebra mussels constituted more than 94% of its diet by weight. These were not birds simply sampling a novel curiosity. They had fundamentally restructured their entire feeding habits and lives around this newly abundant shellfish, thriving winter after winter on the invader's bounty. And the lesser scaup was not unique in this adaptation. The greater scaup, the common goldeneye, the bufflehead, and the redhead ducks all turned to the mussels in prodigious numbers, descending upon the dense beds that now carpeted the shallows as if they were freshly laid banquet tables. Imagine the scene from beneath the water's surface. A cluster of ducks rests upon the cold, gray water in the faint light of a November dawn. One by one, they dip their heads, tightly fold their wings, and vanish, kicking vigorously downward through water made eerily clear by the very creatures they are pursuing. They reach the bottom, expertly wrenching the stubbornly clinging mussels free with their bills, and then swallow them whole, shell and all. The crucial crushing process occurs later, deep within the bird, in a thick, muscular chamber known as the gizzard, which grinds the hard shells into fragments against ingested grit specifically swallowed for this purpose. The bird then powerfully ascends back to the surface, takes a breath, rests for a moment, and dives once more. A single duck can consume many thousands of mussels in a solitary day, and a flock congregating on a productive lake can number in the thousands of individual birds. In those specific locations where these ducks assembled in significant numbers, their impact on the mussel populations became quantifiably measurable. Beds that had densely blanketed the lake bottom in autumn were dramatically thinned by the time the ice broke in the spring. Of course, the ducks could never hope to cleanse an entire Great Lake, for no creature on Earth could consume on such an immense scale. However, in the shallow bays and along the rocky reefs where they concentrated their efforts, they relentlessly pushed back the mussel populations, year after year, effectively removing tons of living shellfish from the aquatic system. And they accomplished all of this without human intervention or cost, adhering to their own ancient migratory schedule, guided by an instinct far older than any human-engineered pipe or power plant. No government agency needed to fund their operations. No engineer had to strategically deploy them. They simply arrived on the wind, satiated their hunger, and continued their journey, precisely as their ancestors had done every single autumn for longer than human beings had inhabited these shores. The second indigenous hero to embrace this challenge spent its entire existence beneath the water's surface, carrying its potent weapon discreetly hidden within its own throat. This is the freshwater drum, a robust, deep-bodied silverfish that frequents the riverbeds and lake bottoms across the central expanse of the continent. It acquires its curious name from an auditory phenomenon. The males possess specialized muscles that vibrate against their swim bladders, generating a low, resonant drumming sound that propagates through the water and can occasionally be detected from a boat above. For the majority of its extensive history, the freshwater drum was an unassuming fish, often overlooked, seldom prized by anglers, merely an unremarkable component of the deep-water ecosystem. Yet the drum concealed a profound secret, and the advent of the zebra mussel would transform that secret into something akin to a biological superpower. Tucked profoundly within the back of the drum's throat lies a remarkable anatomical structure known as a pharyngeal mill. It comprises a set of heavy, bony plates densely studded with teeth, strategically positioned where the throat transitions into the gut. This specialized apparatus functions with the precision of a built-in nutcracker. While most fish must either swallow their prey whole or shred it with the teeth in their mouths, the freshwater drum possesses the unique ability to grind hard shells into fine powder deep within its own body, long after the prey has been ingested. When zebra mussels began to carpet the lake floor by the millions, the freshwater drum discovered itself almost perfectly equipped to exploit a food source that virtually all other fish species could not even access. However, the most captivating detail concerning this grinding equipment is its fascinating transformation as the fish ages. Scientists who meticulously examine the drum's pharyngeal teeth observe that they undergo a profound change over the animal's lifetime. In a young drum, the teeth are slender, delicate, and sharply pointed, shaped much like a comb, ideally suited for grasping soft, small prey. As the fish matures, these teeth gradually begin to alter, growing broader, blunter, and considerably stronger. In a large adult, they evolve into thick, rounded, molar-like crushers designed for a single, highly demanding purpose: to shatter formidable armor. Researchers meticulously traced this gradual metamorphosis through distinct developmental stages, from the fine and pointed form characteristic of youth through an intermediate configuration to the heavy grinding mill of a fully grown fish. A clear physiological threshold was even identified. Studies determined that a freshwater drum generally needed to attain a length of approximately 265 millimeters, or a little over 10 inches, before its crushing teeth developed sufficient power to render zebra mussels a significant component of its diet. Below that specific size, the shells simply proved too resilient, and the fish could not efficiently break them. But once a drum grew past this critical mark, it became an utterly dedicated mussel grinder, cruising slowly along the lake bottom and systematically crushing the invaders, one after another, hour after hour. In the warmer western basin of Lake Erie, where the mussel populations reached their absolute densest, the freshwater drum emerged as one of their most committed and extraordinarily effective natural predators. It was an indigenous fish that had quietly possessed precisely the right biological tool for tens of thousands of years, a tool that remained without a specific purpose until the day a problem finally arrived that matched it with perfect precision. The third indigenous hero did not, by contrast, possess the ideal tool from its inception. To survive, it was compelled to profoundly change. The lake whitefish stands as one of the most vital fish species throughout the entire Great Lakes system, a sleek, silver, deep-bodied species that has sustained both the intricate ecosystem and human communities for countless generations. Long before the emergence of bustling cities and massive freighters, indigenous peoples depended upon its rich flesh. And for more than 100 years, it has served as the anchor of commercial fisheries across the entire region. For almost the entirety of its history, the very existence of the whitefish revolved around a single, unassuming creature. Across the soft, deep bottoms of the frigid lakes resided a small, shrimp-like animal named Diporea, an oil-rich amphipod brimming with fat and vital energy. To a whitefish, Diporea represented the perfect meal, calorically dense and easily found in immense quantities. The whitefish grew large, robust, and incredibly abundant, sustained almost exclusively by this single prey. It was the silent engine that propelled the entire fishery. Then, the mussels irrevocably altered everything. As zebra mussels and their close relatives, the quagga mussels, spread across the deep lake floors, filtering an ever-increasing amount of energy out of the water column, the Diporea population experienced a steep and utterly devastating collapse. Across vast expanses of the lake bottom, where these tiny amphipods had once swarmed in countless numbers, they simply vanished. Scientists continue to debate the precise sequence of cause and effect, but the profound consequence was impossible to overlook. The whitefish had been deprived of the very food source that had sustained their kind for centuries. For a fish so profoundly specialized on a single prey, this loss should have precipitated an extinction-level catastrophe. And initially, the impact was indeed severe. With diarrhea gone, many whitefish grew thinner, their growth rate slowed, and their reproductive output diminished. Their bodies exhibited unmistakable signs of the strain imposed by a vanished food supply. But then, the species accomplished something that ecosystems are capable of in ways we consistently underestimate. It adapted. Denied the fundamental prey that had defined its very being, the whitefish turned to whatever the strange, transformed world now offered. They began consuming the very mussels that had triggered the ecological collapse, plucking small zebra mussels directly from the lakebed and pricing the shells as effectively as they could. Moreover, they diversified their diet to include yet another invasive species, the round goby, a small, bottom-dwelling fish that had arrived in the exact same wave of ballast water and which itself fed extensively on mussels. In doing so, the whitefish seamlessly integrated itself into a wholly new food web that had not existed a single generation earlier. It could not resurrect the lost world of diarrhea, but it discovered a path to persist in the altered world it had been presented, drawing its energy from the invaders along two distinct avenues: by consuming the mussels directly, and by preying on the gobies that had grown robust and abundant by feeding on those same mussels. It was neither a clean nor an absolute triumph. The whitefish found in the lakes today are not always the rich, heavy, oil-laden fish that older fishermen fondly recall. However, survival itself represented a genuine and remarkable achievement. And it unveiled something profound about these aquatic environments. The lakes were not simply spiraling into utter ruin. Quietly, beneath the surface, they were intricately rewiring themselves into a novel and previously unfamiliar configuration. And this process of ecological rewiring did not conclude with the whitefish. To truly comprehend the depth of this transformation, one must trace the trajectory of the round goby, because that single fish reveals just how comprehensively the invasion rebuilt the operational machinery of the lakes. The round goby was the second uninvited visitor, arriving in ballast water just as the mussels had. A small, large-headed bottom dweller, its appetite was perfectly suited to this new ecological reality. Where most native fish struggled even to breach a zebra mussel's shell, the goby specialized in them, expertly prying the shellfish loose and crushing them with its own powerful throat teeth. The mussels were converting the lake's available energy into living shells across the entire lakebed, and the goby had discovered an effective means to unlock that stored energy and channel it back into fish biomass. Goby populations exploded across the Great Lakes, in some areas achieving densities of dozens of fish per square meter along the rocky reefs. This population boom did not escape the notice of the predators residing higher up the food chain. The smallmouth bass, a highly prized native sport fish, discovered that the gobies were abundant, easily caught, and packed with vital nourishment. In many regions, the bass significantly altered their diet to feed heavily on them. Walleye fish learned this same crucial lesson. Lake trout, yellow perch, and even fish-eating birds and water snakes along the shorelines began to capitalize on this new abundance. A strange and elegant pathway had quietly materialized. Energy that the mussels had entracted from the open water and sequestered within their shells on the bottom was now flowing back upward to the apex of the food web, transported on the backs of the gobies into the very predators that anglers and ecosystems value most deeply. It was, in its own unexpected way, a form of accidental ecological restoration. The open water food web, which the mussels had severely depleted, was being partially reconstituted by a new food web anchored firmly to the lake floor, tracing a path from mussel to goby to predator. The lakes were no longer identical to their former selves, yet neither were they barren. They had evolved into something novel, a freshly assembled system in which the invaders had been integrated into the diets of the native inhabitants, nourishing them, sustaining them, and, in a curious sense, being harnessed for their benefit. It would be convenient, and indeed emotionally satisfying, to conclude the narrative here, with nature quietly prevailing and native creatures triumphantly repelling the invader. However, the complex reality of any ecosystem is seldom that straightforward. Honesty demands that we also recount the more challenging aspects of this tale. As scientists examined the invaded lakes with ever-increasing scrutiny, they uncovered a troubling and unforeseen consequence stemming from all this filtering and feeding. Zebra mussels, by clarifying the water, reshaping the lake bottom, and rerouting the flow of energy throughout the system, were also fundamentally altering the manner in which a hazardous element moved through the food web. That element was mercury. Mercury exists naturally in the environment and also descends from polluted air into lakes and rivers. There, specific types of bacteria can convert it into a form known as methylmercury, which living tissues readily absorb. Once mercury enters a fish, it remains there. It steadily accumulates over the animal's lifespan and becomes further concentrated at each successive step up the food chain, a relentless process called biomagnification. Consequently, a large predatory fish carries the accumulated mercury from every smaller creature it has ever consumed. A study published in the year 2024 meticulously compared lakes that had been invaded by zebra mussels directly with similar lakes that had remained free of the creatures. The findings were genuinely sobering. In the invaded lakes, walleye, one of the most popular fish for consumption across the region, contained mercury concentrations approximately 72% higher than those found in walleye from uninvaded waters. Yellow perch, another highly cherished catch, exhibited even more pronounced increases. The practical ramifications extended from the very bottom of the lake directly to the dinner plate. Because fish living in invaded lakes now harbored higher levels of mercury in their flesh, public health advisories, which caution people to limit their fish consumption, began to apply to smaller fish sizes than they had previously. A walleye once deemed safe to eat might now trigger a health warning. The mussels, simply by filtering the water and reorganizing the intricate food web, had inadvertently amplified a toxin that directly impacts human health, particularly for children and for individuals who frequently consume fish from these waters. This constitutes the uncomfortable equilibrium that lies at the very core of this story. The native diving ducks, the freshwater drum, and the lake whitefish were indeed all actively resisting the invasion, consuming millions of mussels and integrating them into the vibrant tapestry of the lake's living web. That response was tangible, and it mattered profoundly. Yet, the very same sweeping transformation that nourished those creatures also incurred unforeseen costs, ones that no one had requested and no one had anticipated. Nature was not merely mending the damage and restoring a bygone era. Instead, it was engaging in a complex negotiation with the invasion, forging a new and intricate arrangement, and arriving at an equilibrium that was neither the pristine lost world of before, nor the utter catastrophe that had been so greatly feared. It was something entirely novel, and like most new developments, it represented a blend of both gain and loss. Step back from the specific details now, and a far grander panorama comes into sharper focus. When the zebra mussel first arrived, human observers often envisioned two distinct possible futures for the lakes. In the first scenario, the invader would be decisively vanquished, scoured from the waters through immense human effort and ingenious solutions. In the second, it would systematically devastate everything it touched, leaving the once vibrant lakes barren, unsettlingly clear, and ecologically vacant. Neither of these predicted futures actually materialized. Instead, something far more compelling and profoundly instructive occurred. The ecosystem absorbed the monumental shock, steadfastly refused to simply succumb, and began a profound process of reorganization around the permanent presence of the newcomer. The mussels were never eradicated, and they never will be. They persist today by the trillions, blanketing reefs, choking pipes, and covering riverbeds across half the continent. The chemicals, the scrapers, and the filters continue their operations at intake structures, because that specific struggle, quite genuinely, never ceases. But in the vast open waters, in the immense, wild expanses where no human hand could ever reach, the native species mounted a response that no engineer could have ever conceived, and no budget could have possibly funded. The diving ducks transformed the mussel beds into an expansive winter feeding ground, stretching across thousands of miles. The freshwater drum deployed a powerful crushing mill it had carried, unused for this specific purpose, across uncounted eons. The lake whitefish entirely reinvented its own diet from scratch, to endure in a world turned fundamentally upside down. And countless other creatures, including the gobies, the perch, the walleye, and even the unseen bacteria within the sediment, all shifted and adjusted in turn, each responding to the others in a vast, sprawling, and utterly unplanned act of collective adaptation. This is the inherent behavior of living systems when we are not actively observing them. They are not fragile museum exhibits, frozen in place and passively awaiting shattering by the slightest disturbance. They are dynamic, perpetually restless, profoundly patient, and astonishingly inventive. Confront them with immense pressure, and they do not simply break and surrender. They bend. They meticulously reshuffle their constituent parts. They engage in cycles of experimentation and failure, followed by further experimentation, slowly reassembling themselves into novel arrangements that possess the capacity to cohere and endure. The outcome is almost never a precise return to the way things were before, but it is also almost never the definitive end. More often, it marks the genesis of something entirely different, something that no one could have predicted, and no one meticulously designed. Humanity expended colossal sums and immense effort battling the zebra mussel, and that work was undeniably vital. It safeguarded the pipes, the power plants, and the water systems upon which millions of people depend every single day. Its significance should not be diminished. But the deeper response, the one that permeated the entire living web of the lakes, originated from creatures who sought nothing and received no compensation, who simply acted in accordance with their ancient instincts, and in doing so, unveiled a profound power inherent in the natural world that is far too easily overlooked. Within all of this lies a quiet and enduring hope. We so frequently frame the narrative of invasive species as a tale of unadulterated and permanent loss, a stark record of damage that can never be undone. And those losses are indeed real, and they warrant our solemn mourning. The world of these lakes, as it existed prior to the mussels' arrival, will not reappear within our lifetimes, and perhaps not for many generations to come. However, the very same waters that endured the invasion also revealed something genuinely worth cherishing. Life does not passively await our rescue. Given even the smallest opening, even the slightest opportunity, it pushes back with a force and a creative ingenuity that can truly take one's breath away. A duck folds its wings and gracefully descends into the cold water. A silver fish grinds a tough shell to dust deep within its throat. A whitefish, against every expectation, learns to thrive on the very organism that nearly brought about its demise. So, the next time you stand at the edge of one of these magnificent Great Lakes and observe the surface ripple beneath a vast autumn sky, remember what is transpiring just beneath it, beyond your sight. A slow, patient, and utterly unstoppable act of ecological restoration is underway there, carried out by creatures who will never know that anyone might bestow upon them the title of heroes. They are not striving to save the world, they are simply living, performing the roles they were evolved to fulfill. And in that simple, tenacious living, they serve as a profound reminder of something we should never have forgotten. Nature, when afforded even a modest opportunity, is far more resilient, far more resourceful, and far more replete with astonishing surprises than we ever dared to imagine. The water is clear, the work continues quietly, and life, against all odds, persistently finds its way forward. For a deeper understanding of the planet's intricate narratives, subscribe to our channel.